one of our planning partners, Michael Clement from Architectural Resource, tomorrow he has offered to create, during the networking session, another one that we had promised to do and then got pretty busy, but he wants to connect you all as job seekers, employers, and students all together in a special Zoom sort of format. And so I just dropped in some information in the chat. We'll have the link tomorrow, so at 8 o'clock tomorrow. If you're a student looking to talk with employers, if you're an employer looking to meet students or people looking to get hired, those of you looking to work and hire in the net zero job market, whatever that means, tomorrow, 8 o'clock, we'll have that link. We'll send it out. We'll send it to you. Thanks to Michael for providing that space. It'll be an alternative to the discussion. So we're still going to have our discussion and networking event here, but it's going to be another opportunity to do that. We've also submitted the student resume book. So if you haven't seen that yet, it's in the handouts. So if you're looking for people to hire, oh, and sorry, it sounds like they're going to start actually at 8:30. So it'll happen at 8:30 after our, after our network session is going, and we'll make an announcement when they can transition over to that. But anyway, we've also got the student resume handouts too in the links and on Dropbox, so download that, reach out to them. Think about who you want to talk to tomorrow. And if you're an employer, send us over some links of either your job offerings or what you're looking to put together, and we'll send that out too, just so that people have that ahead of time. Or internships, that's great too. Do you have official internships you might be starting? So we want to have that conversation going and get jobs going in the net zero field, so we can move the industry forward. We didn't get a chance to talk about water heating capabilities with geothermal, but believe it or not, it can also heat water. And maybe that you all did in the technical one, but we didn't in the novice side here in track 1. So I wanted to bring in, either Alan Waller or Scott Drell from Enertech, just to talk a little bit about some of the different opportunities there are and technologies for heating water. So Al, I promoted you, and if you want to unmute yourself, why don't you jump in and just tell us, is it possible?
Yes, we have a water-to-water unit. Can you hear me?
Yeah, we can.
Thank you. Thank you for introduction. We do have water-to-water equipment. In fact, I have a small 25,000 BTU water-to-water unit in my basement that we heat the water and store it in an 80-gallon tank. And it's very efficient, especially like in the summertime when I'm pulling heat from the house and the heat is being rejected into the loop field. Well, every morning we're taking heat from the loop field and heating our hot water. So it helps maintain a good loop temperature and so forth. Also, in a commercial application, the inner offices of a commercial building, or even a computer room, or a type of thing where they need air conditioning or cooling all year round, where the outer glass area might need heating, that loop would be a very good efficient loop also, because you're cooling and heating with the same loop during the same period of times. But yeah, water to water, in-floor heating using air handlers, and then we can reverse the water to chill the water down, so we could do air conditioning with it also. So there's many applications that we can do. In fact, we've manufactured units now up to 300 tons for Ball State University, Florida State University, that type of thing. So we're doing a lot more larger type applications with in-floor heating also, 10, 15 tons of equipment, 140,000 BTUs going in floor heating. So, but it is very feasible to do, yes.
Thanks, Al. And yeah, we've got Scott from Enertech. And Scott, I don't know if you want to add to any of that from your systems, from a water heating standpoint. What opportunities do you see there? Do they pair up, can it be a standalone, or is it paired up with heat pump water heaters, electric, gas? What do you have?
Yeah, actually, I'll just write off what Al was saying. Agree wholeheartedly with what he's saying, and just to clarify what you were asking, Brett, there's two ways to go about water heating with geothermal. it's very common to have what you call a superheater that's part of a packaged geothermal unit. And as Al was pointing out, you get most of your hot water generation during the summertime, because what that unit is doing, instead of extracting or rejecting, I should say, all of the heat that it's pulling from the home and rejecting it into the ground, it's taking some of that excess heat and using it to provide hot water for the homeowner. So that's one way. And it's probably worth calling out that when you're getting hot water in that way, that is only generating when the unit is running, which with Geo, usually that's going to be more often than conventional equipment. Then, as Al pointed out, there are ways to produce 100% of the domestic hot water using a standalone type of unit, such as a small, like he said, 2-ton high temperature water to water unit, and or some of the other water to water technologies that are out there that can do both the heating, cooling of the home and provide 100% domestic hot water. You know, we have everything from an inverter driven variable speed unit to a 2-stage to a single stage. So you know, you really have a lot of options when it comes to geothermal and domestic hot water heating.
Yeah, great. Thanks, Scott. You know, the other thing I'm thinking about with Geo, and again, maybe this was in the advanced track, but you know, I thought I've been hearing about opportunities now for these just more these urban, really tight lots where you've got to really just maybe drill in somebody's basement to get down and without being too disruptive to the space. What are you seeing out there for opportunities where it's just maybe was more difficult in the past to bring in geothermal? And Al, I'll throw that to you first.
I have 5 vertical bores out in front of my house, and they went 200 foot deep. So each circuit is 400 foot of tubing. And I have a very good performing loop. In fact, I am connected to the Symphony Wi-Fi program, which monitors my inlet and outlet water temperatures and gets my HE and HR numbers, heat of extraction and heat of rejection, and basically calculates the BTUs I'm transferring. So like during the polar vortex a couple of years ago, when the temperatures were below 20 below wind chill, and my loop in my unit was running very hard, you know, to maintain my maintain the home temperature, but it maintained at 70 degrees, 68, 69, wherever we like to set it. But then my loop temperature got down to 35, and then a week later, as the temperatures got up above 0, but still not above freezing yet, and my unit got to cycle a little bit better, I noticed my loop temperature came back up to 41 degrees, and that right there showed there's your renewable energy and constantly picking up the heat. Now in a horizontal loop situation, you might not have that quick of a heat recuperating, because you're only about 5 to 6 feet down maybe, and you're just below frost line. And then at that point, they might be using 600 to 800 foot of tubing per circuit. So they might have 5 circuits spread out every 14 foot and space them out. But as we continue to pull heat from the earth, we sink that earth, and it takes a little bit of while to recover, especially in that situation where going down in a smaller lot or application. Now, commercial wise, here in Cassopolis, we did the Midwest Electric co-op facility, and they did, I think, around 80 to 100 loops there, vertical at 350 foot deep. So again, depending on the load and what they calculate, we can figure out what the BTU capacity is that we can extract from the earth and maintain good temperatures and stuff for the home or the business.
Great, thanks. Yeah, and Scott, I don't know if you had anything to add to that on just some of the challenges on these tighter lots.
Yeah, I mean, and Courtney even showed in her presentation, now that was a larger scale project, but certainly with pre-planning, you know, even on smaller projects, you can get in there and get a vertical put in. And then if you're talking going through a basement, you know, probably obviously just depends on the size of the job and the equipment that has to do the drilling. But certainly I would think that there are opportunities to get those vertical bores going, but I think Courtney would probably be able to better speak to that if she's still on with us.
Yeah, she is. I mean, if you want to chime in, if you're still listening in, Courtney.
And also Rob Dirksen has some
Right, and
information.
yeah, Rob, I can promote Rob too if he wants to chime in.
Oh, I'd like to mention one more thing. Tomorrow you're going to have Speaker Matt Grokoff with the Viridian Country Farms here outside of Ann Arbor, and they're going to do vertical bores right where the garage area would be, and then penetrate the basement wall so these smaller homes that they plan on building might have 2 vertical bores that would be underneath the garage floor area, and then go directly into the sidewall of the garage or the basement area where the geothermal unit would be. So that was their plan in order to offset those small lot style type applications.
Mm-hmm.
So yes, if I can chime in real quick, depth, go deeper. So the Michigan State Capitol, obviously very tight, downtown Lansing, not a lot of real estate. We went 554 feet in the ground. Depth, we can go deep to accommodate a load that maybe doesn't have a lot of space. So it's why we really promote as an industry to size the loop field appropriately to the home. And that includes using things like special grouts or different types of pipe. And again, there's so many different design opportunities. For instance, the project that we're drilling in the state of New Jersey right now, that's 850 feet deep for a campus loop. So there are so many options that it's really site specific. Sorry, dog barking. But they're really drill deeper. There's really not a reason, maybe depending on geology and where you are, but yeah, we can always look at how many loops, how many ton we can. I mean, we've done homes with a single hole, just one, and going deeper under the driveway.
Courtney, what would be more optimal if you have lots of land and lots of water, pond space for geo? Example, there's 3 acres of pond, 10 to 20 depth, all on the owner's lot. I'm sure you get that question.
So I would love to do more ponds. The tough part with ponds is that they have to be owner owned, right? Otherwise, we have a permitting process that's super long. When we're in a public waterway, that permitting process is 6 months or better, because you have to go through a public hearing. They're going to ask a lot of questions. They're going to allow the neighbors to ask questions. It 100% can be done. There's a pond loop actually in Lake Macatawa for the boatworks, right under their docks. But absolutely that can be done. But it's all about space. So when we're talking about a pond, I'm going to ask questions like, is it spring fed? Is the water moving? Are you going to put a boat in it? Because we want to make sure you're not going to put an anchor right through the loops we're going to put at the bottom. But absolutely, there's a plethora of options with a pond. That and the proximity of the home to the pond. You know, an average house needs a 500-foot trench. If the pond is 200 feet away, we might as well just put a horizontal in between the pond and the house. So, but still, yeah, absolutely. A pond loop, if it's close enough, is probably the most cost effective, but a horizontal system, just an open cut trench, if you've got the space, is the most cost effective way to do a closed loop.
Yeah. Hey, Rob, good to see you. I don't know if you want to add to that.
Yeah, just in terms of technologies, I've been following on LinkedIn. There's a group out of Chicago, I believe, called Geothermal Drilling Solutions. They have a product called Rig in a Box. And their challenge in the city of Chicago is obviously finding available land space just to drill a loop. And they have a technology where they actually put the portable rig in the basement of the home. They use the structure of the home as support or downward pressure to drill. Now, obviously, every state and every municipality is going to have different regulations. And we have to make sure that, you know, what we're doing is safe for the aquifer and safe for the structure, et cetera. But there's some really innovative technologies out there for challenges like you're describing. If you just don't have yard space available, there's some folks focusing on that part of them. And that might, you know, come to fruition in Michigan at some point, but it's out there, it's being done. You know, I'm sure they have plenty of case studies to show that valid and working.
Yeah, Michael. You're muted, Michael. We can't hear you.
Hey there, is that any better?
Yeah.
Okay, great. Rob, it's great to see you again. And I want to acknowledge Rob. He was instrumental in that Living Building Challenge project he discussed earlier in his presentation. And Courtney, thanks for all the efforts that you're doing too. One quick question: when we think about pond or standing water source for geo, is the ecology and the impact of that on the ecology of those systems. Can Rob or Courtney, can either of you speak to that?
I'll make a comment on that, and then Courtney jump in as well. When you select a body of water that is ample in volume and in surface square footage, the thermal impact on that body of water is minimal. And so we won't have an impact on the ecology of that pond. Where you'll run into trouble is if you try to put too large of loop in too small a body of water. So a general rule of thumb in our industry has always been 3,000 square feet of surface area per ton of geothermal loop or equipment size at a depth of 10 feet. And so that's a fairly safe rule of thumb. I know there's applications out there in Indiana. I think Water Furnace's facility with their pond loop kind of breaks those rules, but it's a commercial building, so it has a little different profile than you would see on residential. Body of water size and depth are critical.
Hey, there we go. Rob, have there been any independent third-party, non-industry sponsored studies that might verify the minimal impact on the ecological system? The only reason I'm asking that is I think we're all becoming much more aware of our impact. Where we thought that we were making a small dent, we're actually changing planetary climate. So I'm not doubting you. I'm just wondering if you could, and we can connect after this presentation, but it'd be really interesting to see if there's some other folks who have been actually doing some studies on that, because it's a very effective way. It's a very source of heat exchange. It's ideal as long as we're not messing some other things up, inadvertently, obviously, and well intended for sure, but just being dialed in on that. And the only reason I'm bringing this up is that in my travels and in my evolution here, I'm becoming much more aware about impacts that I never even thought. Be mindful of the wake we make conversation.
I can appreciate that, Michael, and I think that there's probably some studies out there. I couldn't quote them now or cite where they would be. We would have to do some research on that. In the overall scheme of we focus on residential as a company, it is less than 1% of our business is pond loops. It's a very small portion of what we do, and so the applications are not that plentiful for studying in my market, but certainly I'm sure other markets have some data and we could do some research and probably find that information for you.
When you're doing, I would assume this question, and John, feel free to chime in if you want to add to it. John Freeman, one of our planning partners from GLREA, but when you're doing vertical drilling, what kind of unexpected surprises do you find? Can that do damage to the aquifer water? Can it bring up radon and add radon to the area? What are you seeing out there, Courtney?
Yeah, absolutely. So we, as I kind of hit on, we drill across the country, and we do run into issues where we have an artesian flow. So that's happened a couple times here in the state of Michigan. A lot of times in an artesian area, people don't know it. And there are a couple of ways to overcome it. Too big of a flow, that's a difficult one to overcome, and you're going to end up looking at something other than vertical. But it's, if I can nerd out just a little bit about drilling technology. So there's a reason that we really enjoy drilling with mud rotary, because we're using mud to carry cuttings out of the hole. We can also use mud weight to help keep things down, like methane or other substances that are below surface. So it really allows us to safely drill those systems without exposing the area. There have been areas where we've gone into that they have warned of pockets, but again, if we can keep our mud weight and our drilling technology the way that it should be, they shouldn't cause that big of an issue. But but there is always unexpected items. We cannot see anything below the surface. So like the rock that I showed in my presentation, I mean, the thing was, we could not pick it up with our excavator, let alone things like, I see John's question about hitting springs or pockets of gas, but it literally is up to the driller, and that's part of us being good at what we do and understanding that technology to make sure that we're protecting everything around us.
Looks like you agree, Rob.
Yeah, the important thing here is that contractors partner with people that know what they're doing and they have the experiences in the market that they're drilling. The state of Michigan has done a good job of protecting our aquifer and regulating drilling within our state, which usually regulations come along kind of like a third wheel. But in this case, we have such a wonderful resource here in our aquifer, and these kind of regulations have really protected our aquifer and our groundwater. And it's kept a lot of out-of-state drillers that just don't know our conditions and don't follow the same guidelines out of our state. And it's keeping the money and the resources here in the state for the work.
Mm-hmm. Michael, you clearly, as an architect, have a lot of either pending or near or net zero projects in Michigan and across the country, I think. And so like when you're advising folks with your projects, yesterday you talked about, you took us through a great project. It was a geothermal powered project. I mean, is that the way really to get to net zero? Is there any other way to do it? What do you usually recommend, or what do you see?
Okay, that's a really great question, and kind of core, at least in the work that we're doing, is all electric house. So from there, it's an easy step to geothermal or air source heat pump. And the key thing is moving to renewable resources for our energy generation. So, if I look back over the course of our work that we've done, geothermal has been the foundational work for just about at least 80% of them. I mean, we're starting to move into air source when we're getting into some of the more higher performing building envelopes, passive house level building envelopes. But geothermal has been literally the bedrock of most of our high performance homes. And Rob has been involved in many of them.
Awesome. Well, I don't see any other questions here on geothermal, but if there are any that come up, let's can keep the conversation going. I did want to. Oh, Michael, do you have something to add?
Yeah, for Rob and Courtney, we run into this a fair bit. We're talking to someone about a high performance home. Inevitably, the conversation of geothermal comes up, and 9 times out of 10, the story is, yeah, Uncle George or Bob down the street or some put in a geothermal, it never worked, the house never got hot. Run into that all the time. So can either of you or both of you address what I think the answer is, but I'd rather hear it from the professionals?
Sure. Like any heating and cooling system, geothermal is an applied product, and it needs to be applied by the right professional. The bottom line is when you hear horror stories of products that don't work, we've heard horror stories of homes that have gas furnaces that won't heat, or air conditioners, traditional air conditioners that won't cool. And there's been something wrong with the application of the technology, not the technology itself. So it just boils down to partnering with good people that partner with good manufacturers that have industry-specific training, product-specific training. We commit ourselves to keeping all of our technicians and installers up to date on new technologies as they become available. We test those new technologies in our own homes before we bring them out to our customers. It's just good, solid business practice to make sure that you are the professional in your industry.
I'd like
Honestly,
to
when I
add.
hear those, I offer to help. I have done so many home shows, and I invariably get somebody to come over and tell me how much what I do for a living sucks and it doesn't work. And I'm like, well, then let me help you. let me come to your house. Let me look at your energy bills. Let's take a look at your unit. Let's figure out what's going on. And I will be honest, so many times when we go look at some of the issues people are having at their home, sometimes it's the geo unit, sometimes it's not, and they have some plug load that has randomly started just sucking energy out of their house. So, but I will be honest, I 100% will offer to help. Anytime someone says that, if you will offer me a negative review, then I will offer you my help to fix it, because I want to make sure that we're being good stewards for the market, because that's the kind of thing that will, regardless if it's geo or any other market, but that kind of negative press helps or hurts everyone. So if I can help, that's what I do every single time. And then they quickly, oh, well, you know, I don't know. And I'm like, no, you can't come tell me a negative and not let me help you. So 100% it is, I agree with Rob. I will offer to help, and then it's training. It's part of the reason that I'm on the national organization now, is I really am passionate about making sure that training is appropriate from technicians for locations like Rob, down to engineers and architects like yourself, everyone, just making sure that we're all on the same page about how these systems should go in to make sure that they're the best that they can be.
Can either of you guys talk a little bit about the whether the output from a geo is more effective, is it in a radiant situation or in a forced air situation? And Rob, I know that we did both on the Burbeck at Beacon Springs Living Building Challenge project, but that's a question that comes up a fair bit. You know, which is the most efficient way to move that precious heat energy that we're creating with the Geosystem to the house? Can either of you address that?
Yeah, if you don't mind, Courtney, I'll go first and then you chime in too on this one. The delivery is really about occupant comfort and what their goals are in terms of their floor coverings, et cetera. We're producing energy at a rate of efficiency second to none. And so whether we deliver that through a forced air mechanism or a radiant mechanism, that's not going to impact directly the efficiency of the equipment. Now, with that being said, a radiantly heated home will tend to feel warmer at a lower ambient temperature. So if we say we're comfortable at 70 degrees in forced air, we may feel the same level of comfort at 68 or 67, or possibly even lower. So by virtue of that, we would be consuming less energy by delivering heat radiantly. Now, the flip side of that is radiant heat can be slow to respond, and that's important in seasonal changes like spring and fall, where we have a beautiful day like today at 57 degrees, and my home through solar gain was rising to 73 or 74 degrees today. If I have an active radiant system, I have a large amount of thermal mass that has to freewheel and let off its energy. That combined with solar gains could really cause the home to overheat. And so it offers some challenges, but I hope that answers the question.
Yes, it does. The other thing that we're looking at, and this is, I was hoping that maybe, and I might be off, but what I have heard is that sometimes the delivery temperature for the geothermal heated house is going to be a little bit less than if you've got a gas-fired furnace where you can, you know, blast it with a heat of hit or a hit of heat. And with the geothermal system, it's more like a hot air balloon. You set it and forget it, and you run at a steady state temperature. And the other things that we run into is duct sizing for air delivery on a geosystem. You want to move more air at a lower temperature, and sometimes that just doesn't play out. So we have some limitations in a retrofit situation if you can't. The house is a system, as I know everyone on this panel understands. Can you guys speak to that?
Sure. Courtney, do you want to chime in on this? Do you want me to jump in?
I will 100% defer to you, but I will tell everyone, and this is a sales pitch I use. I mean, I say sales pitch, but that's the whole purpose of geo. We come in at a little bit lower temperature than what you use for a natural gas furnace. Like in my Geosystem, I'm not going to stand over my register because it's warm, because I don't need to. The whole house feels better. I don't need to interject that high temperature of heat when it gets kind of cold in my house, because I literally set my house at 72. It feels like it's snowing in the summer. My husband loves it. But in the winter, it's consistent all the time. Even on my forced air system, my stuff feels warmer because it doesn't have that time to cool down. So honestly, in general, I prefer the GeoHeat because it's more comfortable. We're moving air more often. Stuff doesn't have time to get cold, so we don't need that big heat push.
Yeah, I use an example, and I used this example 20, 30 years ago when I started in this industry. When we are cold outside and we come in and our hands are cold, what do? We take our gloves off and we put our hands close to our mouth and we blow slowly into our hands and we rub them together and blow slowly into our hands. That's 98-degree air. Now, if we touch a hot pot on the stove and we burn our finger, we blow vigorously on our finger to cool it off. That's 98-degree air. The difference is the mechanism by which it was delivered. So to your point, Michael, is low and slow, lower temperature, slow delivery. We want the geothermal system's air delivery to be such that it's not even perceptible in the home that the system is on or off, moving the air consistently, continuously, and gently at the lower ambient temperature, 98 degrees, and you'll have a perfectly comfortable home.
I just want to remind anyone who wants to jump into this conversation, please do raise your hand like Scott has just done, but and I'll try to unmute you to jump in too, but go ahead, Scott.
Yeah, no, I was just going to say, Michael, and this kind of goes back to the earlier question about people's bad experience, if you will, with geothermal. And I think it's really important to maybe even ask the question back, did you price shop? Because geothermal is a technology that has to be designed, and it should be done by people who know what they're doing. It is not worth, you'll find many times when you're saving a couple $1,000s that shortcuts are being made. You can shorten loops, you can shorten the design process, and that's usually the story behind. And one of the things I often say inside of a home show is, you know, the least expensive geo to have installed is usually the most expensive to own.
Oh, that's well said.
Yeah.
Am I muted?
No, we heard you.
Yeah.
Let's talk.
The what is that Ruskin statement? I'll find it and share it with you, but something along the lines of if price is the only option, then you're fair fodder for you know. Soon after the sweet taste of low price, you're left with the sour taste of performance. Yeah, that's very good input, Scott.
Well,
Yeah.
well, let's talk about helping with that price tag. The question that came in is the tax credit. Is there tax credit available this year, next year? Tell us, you know, maybe Larry, if you want to chime in, I unmuted you. I mean, what's going on policy-wise? Do you think it's going to get extended? You know, it's kind of a crazy question, but what kind of advocacy is going on out there, and how can that help?
Well, I'll chime in quick since I seem to have lots of conversations with the national group. So GEO is the national, we'll call them lobbying, but they're the advocate as far as policy goes. It is their intent to have it go back to 30% and extend through, I believe, 2026. And they're also looking for parity with solar on the commercial side, and do feel very positive that they will get that parity with solar for 30% tax credit on commercial. We just heard that at our national our Michigan conference from Ryan Doherty from GEO. So there is lots of movement on the ground. Obviously, there's a lot going on in Washington right now with them trying to get COVID relief out to the country. But they're very encouraged by a lot of the meetings that they have in Washington about getting those very, very soon.
Is there a partnership with the solar industry? I mean, it seems like a mutual beneficial thing together, right?
I can speak to that. And I think there is more of one today, Brett, than there was even, you know, as you know, that we were written out of the tax credit for a short period of time. And I think that a couple things are being done that the same conference that Courtney just mentioned is that we have kind of integrated into the solar community as far as that conversation. But more importantly, we've worked towards getting geothermal recognized as a renewable so that that can't happen again. And that's really what it comes down to. That way, anytime you talk renewables, geothermal is part of that conversation.
Hmm.
And certainly it deserves to be there. I mean, we talk solar, and we're extracting that solar heat from the ground, and we store our loop in the battery.
Great. There were some other technical questions that kind of flew in here. What is the life cycle span on geothermal? And I want to add to that. I mean, we talk a little bit about product take back, cradle to cradle ideas. I mean, is there a future where the systems could be reconstructed, remanufactured? What does that look like? I think they last a long time though, so that seems like a small issue to worry about for now.
Yeah, there's some published data on the life cycle of geothermal heat pumps is in the range of 20 to 25 year useful on the indoor equipment, the equipment life itself. The underground piping systems is multi-generational. We're talking hundreds of years of durability in the piping itself. So that's going to be something sustainable and long-term that's in the earth that can be reattached to whether it's rebuilt or new equipment in the future. And with technological changes advancing as they are in the electric industry, I think rebuild is maybe a little less likely just because of some of the technologies that are changing, and all of the new implementation of compressors and technologies have to be, they're engineered as a system. So you can't take a new variable speed compressor and plug it into the existing refrigeration system that the current geothermal systems house. There's an engineering differential there.
What about the impact of the COP, the operational performance, the efficiency of the system, or just general electricity use as far as pumps go? I mean, are there more energy efficient pumps out there, or is that, a small portion of the energy used?
Well, it's all a part of the whole system, right? So just like building an energy efficient home, you can't over insulate the attic and ignore the basement. You need to look at the system approach in the entire installation. So using variable speed pumping technology, variable speed or multi-stage compressors, variable speed DC driven blower motors, these are all system components, and there are selections to be made based on cost, based on contractor preference and things like that. But there are definitely new technologies in pumping coming along. The pumping portion is the smallest cost of operation, but is not something that should ever be ignored either.
Brett, that goes back to design also, because there are calculators out there that actually, as you are in the design process, you can plug in different pumps and actually see their energy usage and select the best pump for that application. And of course, the larger system that you're talking about, the more it makes sense to move to something like a variable speed pump, where if you're talking a 2 or 3 ton unit, it probably doesn't make as much financial sense to do that. And the last thing I'll say as far as longevity is, again, back to design. If it's designed to run in that sweet spot for geo, it's more efficient, and therefore the life on that unit is going to be longer.
Well, yeah, I don't see any other geothermal questions, and I'm out myself. But I want to thank you all for your time, and I really want to thank both Enertech and Water Furnace for supporting this conference. I believe 2 years in a row now. So thank you all, very much. Really appreciate it. So
thank you.
Yep.
Thank you, Brett.
I have one quick put in for our 2 geothermal champions. So we're seeing all these efficiency increases in air source heat pumps. Are we seeing something on, like, what do you see down the future? What's coming in the geo world that you can share with us without, having to tell us if you tell us?
You want to tell them, Robert, or do you want me to?
Well, I'll share it one way, Scott, and then you can slap my wrist later. So as I mentioned in my segment on track 2, is the 3 major manufacturers in the U.S. for geothermal heat pumps are owned by the same Swedish manufacturer. Because Sweden and that area of the world is so far ahead in electric technology usage, they're developing a lot of interesting technologies. Working with Enertech as we do, we're seeing Enertech take a really proactive lead in the development of the usage of those technologies here in North America. And so that's about all I can say without, going beyond my non-disclosure agreement. But there are technologies that are in place in Europe. They're on the horizon here in the United States. And it does show to be very promising in terms of efficiency and cost reduction for installation too.
And my approach to that is a little bit more generic, Michael, and that is the beauty of a geothermal, and really the only difference, it's a heat pump, just like air source. We didn't have to fight the battle of keeping electric heat strips from coming on to defrost our system. Our heat strips simply assist us when we get down around that 0 degree temperature outside. As we like to say, when it's 0 degrees outside, 5-6 feet down in the ground, it doesn't know it. And so it's really just, that's why we have an EER and not a SEER rating. We don't have that seasonal change. And so therefore, when you look at it as just a heat pump, there's no technology that's available to a air source heat pump that's not available to a geothermal. It just doesn't make financial sense. And are we going to gain that much more efficiency out of it? That's really what we're looking at.
Hey, Scott, one of our attendees, I think you had a question. You are unmuted if you want to.
Yeah. Can you hear me?
Yeah.
All right, great. Hey guys, excellent conference. So this is Scott Neeson, primarily Minnesota active, but I'm also with Water Furnace as well. The question is excellent about what's next, because we see a lot of really cool things coming, but right now, the biggest opportunity that's right in our hands today is learning how to use the technology that's out there in variable speed and energy and refrigeration monitoring that'll allow them to optimize the design of the system. If you ask me in the next 5-year horizon, what's the biggest opportunity? It's helping our contractors, engineers, architects, everybody engaged in properly applying the technology today. And the first thing I would say about that is that the days of rule of thumb are gone. We're now fully engaged with energy modeling, and we don't need rule of thumb. It was a wonderful way to get off to a start, I guess, before my time. But today, everything really ought to be modeled, and there should be none of this rule of thumb stuff I see out there. The other thing, and again, I see a lot of installs every year, is keep the experiments in your own homes. Unfortunately, the technology's cool. There's a lot of really cool people in the industry, a lot of physicists, a lot of really gamed up people. Keep the science experiments in your own home. Please don't sell them. We are cleaning up science experiments all over my territory. Outside of that, though, this variable speed freak drive technology is amazing in terms of what it can do. However, if it's not understood and installed and designed properly, you won't get the full bang for the buck, right? But great questions. And that is a very interesting part now as we start looking beyond that 5-year horizon. The newer technology that's coming and some of the options that are out there are just amazing. But we are going to have to both address that technology and the knowledge base of our installing contractors. We have an extreme shortage of technical contractors. We have issues to overcome there. On the other hand, we have some great contractors out there. We just don't have enough of them, and frankly, enough of them coming into the industry. So I see workforce development as, and it's not a 5-year window, it's a 10 and 20-year window, because we're going to have to find ways to have interest at a very young age, like there once was in mechanical type systems. Much of that energy now is going into these electronic systems, right? And I have several children who are in the same boat there, and that's okay. But the point is we have some phenomenal technology right here today, some phenomenal technology on the horizon. And if we cannot get our workforce engaged to really understand how to do this, and they continue to fall back on rule of thumb technologies, we'll be in trouble. So those are those big opportunities that I see. And, you know, just sitting in this conference, I very much enjoy it. I live in Madison, Wisconsin area, and thank you guys for all your comments and your input. I think it's raising the roof for everybody. And I found this conference to be incredible. So thank you.
Well, to that point, I think Brett mentioned earlier, tomorrow, as an add-on to this conference, we're having a virtual job fair for anyone who's interested in either finding a career in this industry or offering a career in this industry. At 8:30 p.m., we're going to jump, for those who are interested, we're going to have you jump over to a Zoom portal, and we can put people together, right? And through this virtual means, and maybe we can find some of those young technicians you're looking for.
Right on.
Yeah,
And
go ahead, Scott.
It's not just the young technicians we're looking for. What we're finding in our ultimate contractors is, you know, at age 2, 3, and 4, they're playing with their hands and their mechanical systems. They're getting that, they're having those winning experiences at a very young age that carries them on to the next winning experience and the next one and the next one. And eventually they are geared to work on the kind of equipment we're working on today. And I hate to say it, but some of our best contractors out there, whether they're Apache pilots or coming out of the military, out of some of those backgrounds, that's what we're seeing. And I just really believe it's going to be, it's not a small number of years we're talking about. This is a from cradle to grave kind of career choice. And I don't exaggerate when I say I've had the phone call, Scott, teach me everything there's to know about hydronic in one day. That's what I want. And that's a whole career, as most people know, right? So we really got to overcome that instant gratification idea and have small success steps in the career of young men and women as they enter into this career in order to get them fully capable of putting the technology to use.
Yeah, and one of those success steps looks like what I know these gentlemen have created, and that's a home that has no energy bills. That'll get your attention.
That is a great job. Excellent.
All right. Well, thank you for chiming in, Scott. I just wanted to say that, and Michael, thanks for bringing that up. For those of you who are looking to get employed, share your resume with us. We'll attach it, send it out ahead of time. For those of you having jobs or trying to have conversations about internships or employment, send that out too. We'll send it ahead of time. We did send the student resume book. So if we can get that early, we'll send it out tomorrow. That way it's kind of out there for that conversation that you'll be leading, Michael. So thank you again for doing that. And you know, it's 2 minutes to the hour. And again, I just want to thank all of our planning partners again here, Michigan Energy Efficiency Contractors Association, Great Lakes Renewable Energy, the Michigan Geothermal Energy Association, and Architectural Resource, along with our sponsors, DTE Consumers, Michigan Eagle, T-Stud, and Enertech and Water Furnace, their top tier sponsors. Thanks to them. And Dave Dye, who's our vice president too, has been highly involved in this. Didn't get to see him at all because he's been in the other track. So, and I just, you know, before I close out, this is the utilization conference. So we talked about ventilation, and that is a big part of it. And what we now know, what's been told to us recently from the CDC, just kind of released, is that we do know that COVID has airborne transmission. We do know that it goes through the air, and it is viable in the air for certain amounts of time. So what we do know is that we need to put our country back to work, and we need ventilation, right? We need to increase our ventilation standards. We need to monitor our air quality to see how much CO2 is in our air in all of our buildings. And I think we can really drive a lot of change there. And this is important too for residential, but very big for multifamily, where it can spread around a multifamily building very easily in commercial buildings. So we really hope that you can take what you've learned with building science and apply it and spread the word that, you know, that this is important. This is a key way that this is happening. And we all are building science nerds. We've been telling people for years that, you know, indoor air quality is harming us from toxins, influenza, you name it. So now we just have one more thing to add to it, and we've got people's attention. So let's make a difference out there. Thank you all. I want to see you all in person next year too, hopefully at the next conference. So we really need to get to work. Thank you all. Take care. Have a good night. We'll see you tomorrow at 6 o'clock.
Nice
Thanks,
job,
Brett.
Greg. Thank you.
See you, Michael.